Dear students, in this class we are going to discuss about inter-process communication mechanisms. So here we are going to see how the communication takes place between two CPUs or CPU to IO devices or CPU to peripheral devices. So generally communication means that how the two devices are going to exchange their information with them. Here we can have the communication with respect to two aspects, blocking and non-blocking concept. So in blocking communication, so the process each and every time will enter to the waiting state until it will receive a response from the other devices. Let me take example system A as well as system B, CPU A and CPU B, and each and every time these two systems will receive a response, then only they can exchange data between them. So non-blocking communications, so it doesn't wait for any response, so it has to execute continuously. It allows all the process for continuous execution, so after sending communications. So here there is no need to wait for the response coming from the other devices. So in what way the inter-process communication takes place? By sharing memory or sending a message or sending segments. Let me see one by one. So the first one is shared memory concept. In shared memory concept, how the memory will be shared equally by CPU as well as other IO devices. Here both CPU, then memory as well as IO devices all are connected with respect to the bus unit, and the CPU at the time of writing data, now IO device become busy, so that there will be some common intermediator, that is a shared memory. Now CPU knows about the shared location portion, so that it has to write whatever it want to send the data to IO device. So those informations are available in the shared location memory, and once the IO device become free, now it has to see the content available in the location and it has to give back. So now it is not important thing both CPU and IO device are going to make a great communication with respect to same time. It is not required, because at the time of CPU sending, maybe IO device will activate some other thing, or at the time of sending data from IO device to CPU will do some other activity. So there will be some common mediator in order to share a memory. So whenever CPU become free, so it has to see the data is available in the location and it has to give back. So for that, here we are going for some different scenario with respect to the flag status. So generally CPU read a flag location by seeing the bit 0. So the particular flag called flag is a 0, then it understands the CPU which is going to perform the read operation. And similarly even IO device also, whenever it see the flag status 0, that is also going to read data. And whenever both CPU as well as IO device want to write a data with respect to that particular location, that memory location, so that the flag value set by 1. So both, it may be CPU or IO device, if they want to read a data, then it has to set flag 0, or they want to write a data in the particular location, so the flag again it should be change the position bit 1. So under the shared memory concept, we have a good example, elastic buffer. So here in this example, we can have a great data transmission between one UART to another UART. And here, very important thing about these two system, UART doesn't following the same data rate, because if UART1 on the left hand side, you can see this incoming data rate somewhat greater than the outgoing data rate with respect to another UART, or the incoming data rate somewhat lesser than the outgoing data rate. So here both side the data rate having some mismatches. So different amount of data rate we are dealing here. So for that, we have to use the same concept whatever we have discussed in the previous slide, that is shared memory concept under the buffer. Now the UART1, that is input side, that will forward this information to CPU. So CPU writes the data in the memory in the buffer itself, and this data will be in a compressed format, because it has to write because the data rate will be differ in both sides, so that it has to do the compressed data, and it will be so whenever data rate mismatches takes place between two devices, with help of CPU it is possible. So CPU will write data in a memory in one end, and the other end the UART reads. So that data rate mismatching problem will be solved with respect to elastic buffer concept. And the next example we are having under the inter-process communication, message passing. So message passing is nothing but how two CPUs or how two devices can exchange a message between them. Say in our example, there will be two CPU, and both CPU will exchange a message at the same time, as they can send and receive with respect to them. And here the very important thing, the message is not stored in the particular link, because in both parties they are sending and receiving information at the same time. So no need to store any messages with respect to link. And the third one is signal. So how the signal will be generated from one device to reaches to the other device. Let me take an example, mouse to computer, personal computer, or maybe laptop. There will be a mouse, that is the input unit, and the monitor will be the output unit. Now with respect to these two, with the help of the common medium, maybe wire or wireless medium, we are generating some control signal. So whatever I am, for example, at present I am checking the control signal with respect to mouse to the monitor, so I can able to see some changes, because I am giving some control signal with the help of the mouse unit that may reach us to the other device, that is the receiver unit, so that the control signal will be, or kind of signal will be generated from one device that may reach us to the other device. So generally this control signal, or this signal in the form of analog in nature, that is a kind of interrupt only, because at the time of my presentation I am giving some interrupt signal with respect to the input unit, a mouse. So this will be normally happen in real-time system with the help of the software. Okay, so the signal will be generated by a kind of process, and it will be transmitted to the another process. And that's why I told you earlier, with the help of mouse, that is a one process, maybe one system, and it will be received by another system, that is a monitor. Okay, so you can send a signal from one device to another device. Okay, there will be no return back to the input device. Thank you, students.